Let's talk about where IP addresses come from. We've got a couple different kinds. We have private addresses and we have public addresses. And if I look at my own IP configuration here, here's the IP for my Wi-Fi adapter, 192.168.0.173. That's a very common address. You're going to see a lot of addresses start with 192.168 because that is a private address range. And that means that range can be reused on everybody's network. So most home-based routers are from the factory designed to give out IP addresses that look like this. Anybody can use them. That's the beauty of it. We can use them over and over and over again, which means we can preserve the public addresses for places where those are needed. So Google is not going to use something like this on an external web server because they need it to be what's called routable in the entire world. So they need a unique address that anybody can reach. 192.168 is private. You can't reach that without going through somebody's private router like you have at home. So this address comes from my router. That's who hands it out, but it's private, so everybody's router can hand out the same thing. If you are on a larger network, rather than coming from the router, it might come from a DHCP server. It might even be the same address range. It might be 192.168. But it's configured to come from a computer instead of the router. But otherwise, it's exactly the same. If we think about the network at school that you've seen so many times, we see that 10.118. Well, 10.anything is a private network, just like this 192.168. So 10 can be reused anywhere if it's in that first octet. Now, we're getting this address right here from DHCP, or Dynamic Host Configuration Protocol. What DHCP allows us to do is not have to manually administer an IP address or give an IP address to every single device on the network by hand. So if you have, let's say, 200 computers in a computer lab or several computer labs, if you were doing those statically, you would have to say, all right, this first computer gets .2, and the next computer gets .3, and the next computer gets .4, and it's going to take you all day to set up those computers. And then if one of them goes down or has to be replaced, you have to manually configure it. If somebody wants to bring their own computer from home, you have to manually sit down with them and give them an IP address. What a hassle. So instead, DHCP has this pool of addresses that it draws from and automatically gives it out to any computer that asks. So at school, it's that 10.118, or in your own home, probably 192.168.0, or perhaps 192.168.1. You see both of those pretty commonly. So in my case, it's the router giving that out. Now, there are a couple of commands that we need to know to manage these IP addresses. The first is ipconfig. If we run ipconfig, all it does is show us some basic configuration information about our network. And you can see I have a whole lot of networks here, lots of different Ethernet adapters, Wi-Fi adapters, and these are because I've got VPNs and virtual machines and things like that. But only one of them is active right now, my actual Wi-Fi adapter. So there's my address, there's my subnet mask, which tells my computer how big my network is. So this is my address, but what other addresses are on the network with me? This tells me. And then this default gateway is very important. This says if I want to send my traffic to anywhere that I don't know where it goes, I send it here and this manages it for me. So if I'm going to send it to something else on my network, let's say that I'm sending traffic to my local server that's sitting in my basement right now. It's 192.168.0.2. Well, because it's on my same network, my computer knows how to reach it, so it just does it directly. But if I want to get to the internet, if I want to talk to Amazon or Google or Yahoo or anybody else, my computer has no idea how to get there. So it just forwards it to the default gateway, and the default gateway handles that for me. It does the, it's going to talk to the DNS server, get the DNS lookups, all of this. And then it's going to route that traffic for me. So basically, if I don't know where it goes or my computer doesn't know where it goes, it sends it here. This is the default route for all traffic that we don't know how to get to. Now, ipconfig shows us some basic information, but we can see more by saying ipconfig/all. Now we see a whole lot more information. So here's the same adapter. Here's my Wi-Fi adapter. The same information we saw before. Here's the default gateway. Here's my IP address and my subnet mask. But we see some other stuff as well. DHCP enabled. Yes, it is. So that's where the address comes from. Auto configuration enabled. Yes, it is. We're going to see that in a minute. Lease obtained. So this is whenever we ask for an IP address from the DHCP server, We don't get it permanently. We only get it for the amount of time the lease is set. So notice that April 27th, that's today at 12:43 p.m. So this is just a few minutes ago, I got this IP address. And it expires tomorrow at basically the same time. So I only get this address for 24 hours. That's configurable. I can go into my router and say, no, you only get it for 15 minutes or you get it for 3 weeks. There's a huge range. Most of the time you see it around 3 days, but anywhere from 1 to 7 days is pretty common. You don't want it to go every, let's say, 15 minutes because it's going to constantly ask for and refresh the IP address. It's going to create a bunch of unnecessary traffic. So once a day, that's plenty. We see here is the DHCP server. Here is where I got that IP address from. Notice 192.168.0.1 is the same as my default gateway. In other words, my router is acting as my DHCP server also. I've got DNS servers. These are 2 from Google, 8888 and 8844. I have manually put these in. If my internet service provider were giving my DNS servers to my router to hand to me, I would see those there, which is way more common, but I've preferred these over AT&T's. So this is the expanded information you see with ipconfig/all. Now ipconfig can do more than just show information, it can also modify information. So if I say ipconfig/release, if I run this, it says release that DHCP lease. Notice now, Wi-Fi adapter has no IP address. I've given it away. I said, let the lease go. If I now look at ipconfig, I have a new IP address. Now this one is also important. This one does not come from the DHCP server. Notice this is auto configuration. This is Apipa or APIPA. That is the automatic private IP addressing. Now I've had to run an ipconfig/renew here in order to get my original IP address back, simply because it disconnected me from my network and stopped recording. So we'll go back up here to that Apipa address. So this 169.254. The purpose of this address is for Windows to be able to create a network when a DHCP server is not available. So there's a couple of good reasons for this. Number one, let's say that you're going to have a LAN party. You're going to invite 20 people over, but you don't actually want to put everybody on your internet connection. So you just connect everybody to a switch. So they can all see each other, but they have no route out to the internet. Nobody's going to be updating any games or anything like that. Well, you still need to be on the same IP network if you're going to play games with each other. So there's a couple of things you could do. Again, you could hand out IP addresses to everybody and say, all right, you're .1, you're .2, you're .3, or everybody's network card can automatically self-configure. And when it does this, it will put itself on a 169.254 address, which means everybody will be on the same network. It's kind of like self-assigned DHCP. Now, because these last 2 octets are given out randomly by the computer, it's possible, though really unlikely, that it might choose the same one that somebody else already has. So what it's going to do is randomly choose those 2 and then ask the network, hey, does anybody have, in my case, 166.22? No? Okay, I'm going to keep it. If somebody did have it, then it would get a response. It says, hey, anybody have 166.22? Oh, you do? Sorry, I'll pick something else. So whoever claims it first gets to keep it. Now, realistically, we don't use this very often. It has limited real-world value. What it does tell you, though, and the reason to know about it is because when you see 169.254, it usually means my network card is working, but the DHCP server is not. So that could mean, let's say that you're on a wired connection. I am connected to the switch. The adapter is up, it sees electricity flowing, but I can't get anywhere. I can't get out of the room, or I can't get to the router, or I can't get to the DHCP server. So it tells you sort of where in the network a problem lies. Same thing on wireless. If you get this on wireless, that means you are connected to the wireless access point, but the DHCP server isn't running or isn't accessible. So more than anything, when you see 169.254, while it is an automatic self-assigned address, usually you use that as a troubleshooting tool and say, oh, my adapter is working, but something else on my network is not. So when I do my ipconfig/renew, it says, hey, go back and ask the DHCP server again, and I come back and I got the same IP I got before, which is interesting. Notice that my time is updated. So I requested an IP address and it gave me the same one. And that's what it's going to try to do most of the time. Now, if I were to reboot the DHCP server, I might get a different one. So you're not guaranteed to get the same address every time, but you usually do. Your internet service provider is going to hand an address to your router in much the same way. So they don't say usually, hey, you are .73. They just give you whatever the server wants to hand you. When you go to renew a few days later, you'll probably get the same one. Maybe there's been a town-wide power outage and the server that's handing things out for your internet service provider gets rebooted. Well, maybe you don't get the same one that time. I'd say realistically, I have had an IP address sometimes for 6 to 12 months at a time, and then it'll reset. So that's pretty common. So that's DHCP. That's the automatic private IP addressing, and that's where some private IP addresses come from.